Welcome to Math Archives. In this video, let me discuss about the topic of odd and even functions under Fourier series. Here, I have to take an example. Expand f of x equal to mod x or absolute x as a Fourier series in an open interval minus pi comma pi and deduce 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. that is equal to pi square by 8. So before let me enter into the problem, let me have a short look over the formulas that we are going to use in the given problem. The first one you should know is that is the Bernoullis Formula. Integral u v dx is equal to u v1 minus u dash v2 plus u double dash v3 minus etc. Here both u and v are functions of x. That is u and v both are in product. Suppose both the functions are in terms of x and are in product form, then how to evaluate that integral? For that we make use of this formula. Here u dash represents derivative of u, that is du by dx. You have to differentiate u once with respect to x, and u double dash is you have to differentiate u two times with respect to x, and u triple dash is you have to differentiate u three times with respect to x, like that. So u dash, u double dash and u triple dash are etc. are successive derivatives of u, whereas v1, v2, v3 are etc. are successive integrals of v, whereas v1 is nothing but integral v dx, that is you have to integrate v once with respect to x. v2 is nothing but you have to integrate v two times with respect to x. Already we have to integrate once, so you have to, instead of doing like this, you have to integrate v1 once with respect to x gives you v2. And v3 is nothing but you have to integrate v three times with respect to x. So instead of doing this, already we have to integrate two times. So we have to integrate v2 once again with respect to x, that gives you v3, etc. So v1, v2, v3 are successive integrals, whereas u dash, u double dash and u triple dash are successive derivatives of u. The basic integration and differentiation formula you know already, that is integral x bar and dx, that is if you are integrating this, you get x bar n plus 1 divided by n plus 1. Whereas if you are going to differentiate the same function, that is d by dx of x bar n is nothing but nx power n minus 1. Also, integral sin nx dx is nothing but minus of cos nx by n, and integral cos nx dx is equal to sin nx divided by n. And these are the values you should know. Cosine 0 value is 1, whereas sin 0 is 0, cos pi is minus 1 and sin pi is 0. Cos n pi value is minus 1 whole power n, whereas sin n pi is 0 when n takes an integer value. Here we have to discuss only about integer values, so that sin n pi values takes the value 0. Now let me enter into the problem. Expand the given function f of x, that is mod x or absolute x, as a Fourier series in an open interval minus pi comma pi, and deduce this series. So first what you are going to do is we have to find out the Fourier series representation of the given function f of x equal to absolute x or mod x. That is, given function is f of x is equal to mod x, or you can write it as absolute x. So you have to write the function along with the interval. The function is defined in an interval minus pi comma pi. So as I told you already, whenever you are going to write the function, you have to write the function along with the interval, that is must. Because the case of odd and even function arise only for the two intervals of type minus pi comma pi and minus l comma l, and the case of odd and even function doesn't hold for the intervals of the type 0 comma 2 pi and 0 comma 2l. So whenever you see the function is defined in an interval minus pi comma pi, immediately you can verify whether the given function is of even or odd. For that what we do? So you have to immediately replace the function value, that is x by minus x. What happened? If you replace here x by minus x, that is absolute minus x or mod minus x is nothing but function itself, isn't it? What is the absolute x? That is your f of x, which means f of minus x is equal to f of x. So what it means? Which means therefore the given function f of x is an even function. So for more details about odd and even function, the link is given in the description bar. For more details, you can refer the link. Next, so if the given function is of even, what we do? So which means the value of bn is 0, isn't it? So let me show the table for your reference. So we are under the case of minus pi comma pi. So leave this interval type. So under minus pi comma pi, we have three categories. Either it is of even or odd, or neither even nor odd. Now we are under this category. That is, the given function is of even type, which means we can calculate the values of a0 and an alone. So no need of calculating the value of bn, because the value of bn 0 if it is the given function is of even time. So the required Fourier series B, f of x consists of only a naught an alone. So f of x is equal to a naught divided by 2 plus sigma n varies from 1 to infinity an cos nx. Here we make use of these two formulas for calculating the values of a naught and an. So a naught is calculated by make use of the formula a naught is equal to 2 by pi integral 0 to pi f of x dx, and an is calculated by make use of the formula 2 by pi integral 0 to pi f of x cos nx dx. So now let me first find out the value of a naught. So a naught is equal to 2 by pi integral 0 to pi f of x dx, that is equal to 2 by pi integral 0 to pi. Listen here, the function given here is f of x equal to mod x or absolute x, that is defined in interval minus pi comma pi. So in minus pi comma pi, so in 0 to pi, this is from minus pi to pi, whereas in 0 to pi, absolute x, that is takes the f of x takes the value plus x. Okay, in 0 to pi, if it is a mod function, absolute function, so in 0 to pi it takes f of x takes the value x. So in 0 to pi, instead of writing mod x, so no need to write mod x, that is x. In 0 to pi, absolute x, that is mod x takes the value x. So x dx, that's all. So you know how to integrate x. Integral x dx is nothing but x square divided by 2 with the limit from 0 to pi. So now let me substitute the limit, upper limit minus lower limit. If you replace x by pi, pi square divided by 2. If you replace x by 0, 0 square by 2, which means this term vanish. So you have only 2 by pi product pi square divided by 2. Here 2 and 2 being cancelled, one of the pi also being cancelled, you get only pi. So the value of a naught we have calculated just now for this problem is pi. Next we calculate the value of an. For that we make use of the formula 2 by pi integral 0 to pi f of x cos nx dx. So here the same process, 2 by pi integral 0 to pi, in 0 to pi f of x takes the value x. So that is mod x is nothing but x itself, x cos nx dx. Here both x and cos nx both are functions of x and are in product form. If it is so, we make use of this formula, integral u v dx is equal to u v1 minus u dash v2. That's all. We may not move up to that after u dash, because u double dash means this x is having power 1, so that becomes 0, so we have to stop up to this. So for your clear understanding, I have to write here. So here your u is x and your v is cos nx, and u dash is differentiating u. Once again with respect to x you get 1, whereas once again if you are going to differentiate, what you get? Differentiating a constant gives you 0, whereas v1 is nothing but, so we have to stop up to u dash. So that's why I have to stop this formula up to u dash. Okay, so v1 is nothing but, so integral cos nx dx, integrating cos nx, what you get? Plus sin nx divided by n. Next v2, v2 is nothing but integrating v1, that is v1 is nothing but sin nx divided by n dx. So integrating 1 by n is here, and is a constant, so you have to integrate only sin nx. If you integrate sin nx, what you get? Minus cos nx divided by n. Already you have n in the denominator, so you have n square. That's all. So let me now substitute in the formula. an is equal to 2 by pi of u v1. What is your u? X. v1 is nothing but sin nx divided by n minus u dash is 1. v2 is nothing but minus cos nx divided by n square. That's all, with the limit from 0 to pi. What I am going to do is, I'll just make these two minus as positive in my next step, so that it will be easy for us to substitute the limit without having much confusion about the signs. Okay, so x sin nx divided by n. There is no change in the first term. The second term, you convert this minus and minus as plus cos nx divided by n square with the limit from 0 to pi. So you just mark the x term first. In these three positions we have x. So first what we do, let me first replace this x by pi first and then replace x by 0. Now let me replace, that is an is equal to 2 by pi. So put a big bracket. So 1 is for upper limit minus this is for lower limit. Okay, bracket is very important. So look at here. So what you do, you just replace here pi sin n pi. What happens? Sin n pi value you know already. You know the value of sin n pi, that is 0. So the first term becomes 0. So 0 plus, coming to the second term, cos n pi. You know the value of cos n pi. Cos n pi value is minus 1 whole power n. So minus 1 whole power n divided by n square. So minus 1 whole power n divided by n square. So upper limit over minus. Coming to the lower limit, you have to replace these values by 0. If you replace this x and x value by 0, what happens? The first term becomes 0. Plus cosine 0 value is 1. So 1 by n square. That's all. So you have 0 plus 1 divided by n square. So simplifying this, you get 2 by pi minus 1 whole power n divided by n square minus 1 by n square. So here n square is common. So take it as common. So n square minus 1 whole power n minus 1. So again you have to simplify this. That is, you can write this as a n is equal to. So you have to just replace only the power of minus 1. Power n by either, if it is of odd, we can segregate this into two cases. Either n takes odd values like 1, 3, 5, etc. or it can take even values 2, 4, 6, etc. So let me check what happens if it takes odd and even values. So here let me put n is equal to 1. If you substitute n is equal to 1, what happens? Minus 1 whole power n. Minus 1 whole power 1 is minus 1 itself. So minus 1 divided by n square. So which means, so before that you have 2 by pi, isn't it? So that is 2 by pi. So here minus 2 by n square, which means minus 4 by pi n square. So minus 4 divided by pi n square if n takes odd values. And let me check what happens if n takes an even value. Suppose if you replace the value of n by any even number like 2, 4, 6, now I have to take 2. If you take n is equal to 2, what happens? Minus 1 whole square. Minus 1 whole square is nothing but plus 1. So 1 minus 1 divided by n square, what happens? Whatever may be the denominator, 1 minus 1 means 0. Before that you have 2 by pi, isn't it? So 1 minus 1 means that becomes 0. So numerator becomes 0 means the entire value of this an is 0. So an takes a value 0 if n is even number. So the value of an, that is an value exists only for odd values of n and not for even values of n. So that is the meaning. Now let me substitute the values of a0 and an in the general Fourier series representation, that is f of x is equal to a0 divided by 2 plus sigma n raised from 1 to infinity an cos n x. The value of a0 we have calculated is pi divided by 2 plus sigma. Instead of writing n is equal to 1 to infinity, because here n takes only odd terms to infinity, and the value of an we have calculated as minus 4 divided by n square pi, isn't it? And cos nx. So here this summation is only for n. So here minus 4 and pi is a constant. So take it outside of this summation. So your f of x is equal to pi divided by 2 minus 4 by pi sigma. N takes, instead of writing odd values, you can write this as 1, 3, 5, etc. Both are equal. Okay. So to infinity cos nx divided by n square. So this is the Fourier series representation of the given function f of x is equal to mod x defined in an interval minus pi comma pi, that is in an open interval. Next what we have to do, we have to deduce a series given in a problem. That is, we have to deduce that from this you have to deduce 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. that is equal to pi square by 8. This is what you are going to deduce from this series. So for that what do you do? This is a cosine series. Let me expand this series for your clear understanding. So that is your f of x equal to pi divided by 2 minus 4 by pi. Now you just substitute n is equal to 1 and then 3 and then 5 and expand this series by giving odd values of n. So you have first, if you substitute n is equal to 1, cos x divided by 1 square is your first term, plus second term is cos 3x divided by 3 square is your second term, plus cos 5x divided by 5 square is your next term, plus etc. So this is what the series we are going to deduce. So series of all positive terms, isn't it? So as I told you already, cosine series is obtained in most of the cases. Cosine series is obtained by substituting either by 0 or pi. So here we make use of the value x equal to 0, because here x equal to, if you substitute x equal to 0 means that gives you series of all positive terms. If you substitute x equal to pi, what happens? So you can get negative terms. Okay. So alternative, positive, negative, something like that. So in our problem we have to take x is equal to 0. Okay. So Now, for the function f of x equal to absolute x, we have to deduce the Fourier series representation of the given function. Next, we have to deduce this series from this one. Okay. So now, for that, what I am going to do? Put x equal to 0. Put x equal to 0. So, if you substitute x equal to 0, immediately you can verify whether it is a continuous point or discontinuous point. For more details about continuous and discontinuous point, the link is given in the description box. For more details, you can refer the link. Put x equal to 0, which is a continuous point. Which is a continuous point. Because the function f of x is defined in an open interval minus pi comma pi. Here 0 is inside the interval, which means x is a continuous point. If x is a continuous point, what you do? Let me show this table for your clear understanding. So, if it is a continuous point, what we do? We have to substitute the value directly. That is, you can directly replace the value of the function, that is x by the value itself. That's all. Okay. So, what we do? You just replace x by 0. That is f of 0 is equal to pi divided by 2. So, that is here. Okay. So, in this, we just replace these x by 0. That's all. Okay. So, sorry. Pi by 2 minus 4 divided by pi. So, within bracket you have cos x, that is cos 0, divided by 1 square plus cos 3x. Cos 3x is nothing but 3 0, that is cos 0 divided by 3 square plus cos 5x, that is 5 0, that is cos 0 divided by 5 square plus etc. So, you know f of 0. What is your f of x? So, you know f of x is nothing but absolute x. So, you just replace, since it is a continuous point, what you do, you immediately replace the value of x by 0, that's all. That is f of 0. What is the value of f of 0? Your f of 0 is nothing but 0 itself. So, in the left hand side, you have f of 0 function value, that is the value of the function f of x at x equal to 0 is 0 itself. That is equal to pi divided by 2 minus 4 by pi. Cosine 0 value is 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. So, you just take this term to other side. So, what happens? 4 by pi of taking this term to this side. So, minus become positive. So, 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. That is equal to pi by 2. So, you need this series alone, this side. So, you take this 4 by pi to the other side, you get 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. That is equal to, if you take this to other side, what happens? Pi by 2, that is in product form. So, you have pi divided by 4, okay? That is equal to pi square divided by 8. That's all. This is what the deduction part we need from the Fourier series representation of the given function f of x equal to mod x defined in an open interval minus pi comma pi. So, hope you got a clear idea about how to find the Fourier series representation of the given function f of x equal to mod x defined in an open interval minus pi comma pi, and also you get a clear idea about how to deduce a series from the Fourier series, right? Thanks for watching. See you all again in my next video.